Here we are at Part 2b. If you just kind of landed on this video and you've not watched any from this channel in particular, this is actually the third video in a series. The first one I think was just build a PLC trainer, and that was a little project to build a little hardware demo with a Micrologix 1000, 6 toggle switches, and a 24-volt DC power supply. And we went through step by step, every single little step, every technique needed, every skill needed to build the box. Now we're going to, then we went on to another one. It's the exact same hardware trainer, so to speak, but we're adding a few more devices to kind of max out the capabilities of the PLC and max out the lab projects that you could demonstrate using it. This is actually the second part of that Build a Trainer Part 2. So there's Build a Trainer Part 1. You need to go back and watch that because we don't go over everything, you know, all the techniques and everything that we did in the first part. We don't repeat that in Part 2A or Part 2B. So if you just landed here, you need to go back and watch Part 1 first, then Part 2A, and then come back to here. Now, if you're an old hand with drilling and soldering and everything electronics, electrical, you could skip the first one and just watch Part 2A and B. This was the last slide that we showed you at the end of Part 2A. Now we're in Part 2B. So we did show you I guess you could say a schematic for the trainer at the beginning, and now we're showing you here a wiring diagram. And we're relating this to the inside of the box. So if you look at the dozen holes there, you see 4 large, 2 small in the upper row, and then 6 small in the bottom hole. That exactly corresponds with what you see here. We did it this way to make it a little easier for you to wire this up. Now we're going to go step by step on how to connect the connectors to everything. And remember, we already have part of this done. You know, the lower row there, the toggle switches, notice that the red 24-volt DC line that goes to all the devices, when it comes across the top down to the bottom row and then back to the right, you see it doesn't go all the way to the end. We did solder it up though all the way to the end. So we're going to cut out that section later and then hook a conductor from the middle pin on the toggle switch furthest to the right and run it up to the normally closed contact on that push button up there. Because remember that we are wiring the normally closed push button in series with the toggle switch. And again, this is the open end of the box, and we're relating this diagram, wiring diagram, to the back side of the face of this box. You see red conductors and you see black conductors. Red we normally conventionally use for positive, black for negative. So the very top line there, which I show a little heavier, 24 volts DC, it's correct to say 24 volts DC if it's positive and 0 for common or ground. You don't have to say plus 24 and minus 24. It's really 0 and 24. If the voltage in reference to 0 is negative, then it is negative something. But regardless, if you want minus 24 for black and plus 24 for red, it's going to work out the same, believe me. You follow the red wire across, and then it drops down in between the 2 simple push buttons and the 4 lighted push buttons. From there we have a conductor that goes to each of the common tabs for the push buttons. Okay, but it goes to the common of the push button, not to the light. The red plus there is only going to, from that top line, 24 volts DC, that only goes to the common terminals on the switches. It has nothing to do with the lights. The only difference is that the 3 of those lit push buttons, the 3 in the middle, when you close the switch, it goes to inputs 1, 2, and 3. Whereas the one all the way to the right, when you push the button's already closed, it's spring-loaded closed because you wired up normally closed. So it's wired in series with input 0. So if you follow the path from input 0 back to 24 volts DC, input 0 is wired to one pin on the toggle switch. The center pin goes up to the normally closed on the push button, through the normally closed contact, out the common, to your left, down to the heavier red wire, then up and back over to the right to 24 volts DC. This is easier to follow in the schematic diagram rather than this wiring diagram. Schematic diagrams are meant for reading the electrical design. A wiring diagram is meant to be used for strictly wiring. We're going to connect the lit push buttons, and I have them in a vise here, and I have them at the right spacing so they'll fit in the holes. Now, I did these photographs before I realized I was making a mistake, but since I made the mistake, took photos of it, I decided why not just put it in here and illustrate two of the most common mistakes you can make when you're putting together a project like this. At this point, I'm recording this right now. I could have taken these out. So I'm not doing this to cover my butt. But I made these two mistakes, and I more or less know what I'm doing. Now, I was probably concentrating so hard on the order I was going to do this in and everything, I wasn't paying close attention. Nonetheless, I still made the mistakes. So what's wrong with this picture? I am making two common mistakes. Both of them are visible right here. At this point, you have enough information. If you put it all together, you could call out the two errors. Now, the soldering procedure is correct, but do not solder your lighted push buttons until you have watched the next half dozen slides or so. In other words, don't look at this slide and then go do it. Okay? Wait until I've corrected the mistakes and then showed you the correct way to do it. Now, there's no way you'll make this mistake, especially after I've showed you the mistake. So you see what I did? I have the twisted wire, and I didn't even bother to tin it this time. I have the twisted wire underneath of one pin to the right and on top of the pin on the left, and then the weight of the conductor holds it down snug against that pin on the bottom. So I soldered that joint. Then I lifted the conductor up on top of the adjacent pin, soldered it, left the other one hanging in the breeze, soldered it on the next one, and so forth. Now, the proper way to do that would have been to solder them on the top. That way you have the common connection the furthest away from all the other pins. Now, in this case, we got plenty of space, so it really didn't matter. But you can see I've unsoldered those, so that ought to be a hint about the first mistake I made. You can see some solder at the right spacing, and I've taken them off of the two lower pins. Okay, so here's the common soldered on all four. Okay, so the mistakes. First, I soldered the common to the plus terminal instead of the negative terminal. I want a minus common. It's a black wire. So even though I knew which was plus and which was minus, marked on the back of these lit push buttons, I still soldered it to the wrong terminals. Then, as you see back here, I unsoldered it and resoldered it to the correct terminals. Okay, so I fixed it. Fixed that I did. Then I realized I'd made another mistake, and that is, it wasn't until I got to this point that I'm thinking, oh my goodness, these devices insert from the front, not the back. Everything else I've always used, you slid it in from the back of the panel and put the nut on the front. Now, this is not uncommon. In other words, the bezel is what's exposed on the front of the panel, the nut goes on the back. So at this point, is there any way in the world that you could take these lit push buttons and slide them in the front with that common black conductor soldered on there? Absolutely not. So I had to unsolder and start over. Now, I know you won't make these mistakes, but I thought it was a good idea to share them. It's a very common thing. Another common mistake is like on the toggle switches. You've got a lock nut, you have a locking tab washer, you have a locking washer, and you have a nut. If you slide those on in the wrong order, you're going to be taking it back apart to do it over again. Now you see the little square metal plate with the little spurs or points on it facing towards the front of the bezel? That's to grab a hold of the plastic or the metal on the back side of the panel. So make sure that that square spacer, locking spacer, goes on after you've slid it through the front and then put on the nut. Now also, is there any way you could get the nuts off of these to slide them through the front? Of course not. Okay, so now we need more insulated conductors, wires. I grabbed another cable that has many more conductors in it. Now, it doesn't have enough colors. It's got red, green, orange, blue, black, 3 white, but there's 4 red, and there's 3 black. So there's not even an even number or the same number of each insulation color. But to turn these few colors into more colors, there are little stripes painted on here. I didn't put these on there, the black and the white. This all comes this way. So that allows you to take 4 different red conductors, one with no marks on it, one with white, one with black, and one with the green. That gives you 4 colors with red. Now typically I stay away from red and black conductors for anything but positive and negative. It just makes for easier troubleshooting. And by the way, this stuff is all available on YouTube. It's available on eBay, or you go to your local electrical distributor. I usually go to the local AB distributor, Rockwell Automation. They sell the complete line of commercial and industrial conductors and cabling. Usually they've got a spool somewhere in the back some's been cut off of it, and they'll sell it by the foot. You only need 2 feet at the most of this. So you're going to walk in and say you want to buy 2 feet of something that's $1.80 a foot or whatever it is. Just apologize when you go in, because it's going to cost them more to do the paperwork than what you're going to pay them for the conductor. So you could take simpler conductors and just reuse the same colors. Nonetheless, this is what I'm using. Now, this is a handy dandy tool for stripping the sheathing off of the outside of cabling. So this, you see, has a knurled tooling that's holding the cable snug into a V-notch. We'll explain a little bit about this. If you push that V-notch up, you'll see a cutting tip sticking out from the tip of the tooling there. Let's go back to the previous. On the far right end, you see the little black spline knob sticking out there? That's what you use to adjust how far that cutting tip sticks out this end. So if you have real thick insulation, then you need to run it out a little further, but don't run it out too far, because you don't want to nick the insulation on the conductors inside the sheathing. Okay, so then you put the sheathing in there, and this black V plate here is very strongly spring-loaded. And then you simply just pull you pull at the length of the cable, and it cuts a slit in at the full length. Now there's 2 ways you can use this tool. You see that orange knob sticking out the top? Once you place this tool on the sheathing, you would then take your thumb and push that lever all the way to the other side and then slit it. If you leave it where it's at right here, that's if you want to spin this around concentrically around the sheathing to slit it the circumference of it and not the length. But anyway, if you buy one of these tools, you'll figure it out. Very nice to have if you're going to do a lot of this. Not worth buying it just for the simple project. I just happened to have it for something I was doing, so I threw it in for grins. We're ready to solder up the conductors to the back of these lighted push buttons. Notice it says 12 volts there. You remember I explained at the beginning that this was all I had to use for the project. Now it's a 24 volt DC project. I did not want to add another power supply just to power these lights. I could have done that. So what I did instead was, and you won't see this because I don't show it, I added, I believe, 180 ohms, 280 ohms, I'm sorry. I added 280 ohms of resistance, a half watt of it, in series with the power terminals for the light to drop that 24 volts down to 12 volts so it didn't burn up the lights. Now, you're not going to do this. You're going to buy 24 volt DC lamps to begin with. Don't even bother with the 12 volt ones. Buy the 24 volt DC ones. There's plenty of them on YouTube. Okay, so I'm not going to go over again about tinning and stripping wires. You see the orange one on the bottom with a black stripe on it? I actually soldered that with this switch flipped over 180. So it was coming in through the top of the hole. I soldered it, then flipped it over 180, and now I soldered the orange, the plain orange and plain red, into the common. You can see the C there on the terminal with the red conductor, and then the plain orange into the normally open. These are the three conductors that you're going to solder to every one of those four switches. Remember, you're connecting conductors for both the input and the output devices. And you remember why the negative terminal is not connected yet, right? That's because this inserts from the front of the panel. You can't have any common wires connected until you mount these actually in the panel. Okay, ready to insert into the little box. Look like little squids of some sort, electronic squids. Now, if you look at these four, one of them is not the same as the other three. Give you a second to look. And what you'll notice is that the one with the blue wires, one of the wires is soldered in a different position than the other three. That's because we're using the normally closed contact on that first switch, the one with the red and blue wires. That's going to be used as a normally closed. The other three are normally open. Then we soldered the common wire to the little red plain normally open push buttons. Rather than making sure we had the right distance between them to match the holes in the box, we just made it long. That way we can always flux that wire as we push the switches close enough together. Okay, so here's our three assemblies. Well, actually, 6 assemblies. Each of the blue lit push buttons is an assembly. It's got wires connected onto it. Then we've got our 2 little red push buttons soldered together. Notice the 2 little red push buttons now. One of them has a white wire and one of them has a brown wire. Remember, for our inputs, we've got white, brown, orange, yellow, green, and blue. That matches those 6 switches there. Same as it does on the toggle switches. So that means that the white, the red push button there's the 2 red push buttons with a white and brown wire. That goes to the white and brown toggle switches above it. And then over here we've got a lit push button going to orange, a lit push button going to yellow, one going to green, and one going to blue. So we did that on purpose to give some method to our madness for the colors. Now we insert the lights, the lighted push buttons from the front. That says insert from the rear and tighten nuts down. Well, you insert the lit push buttons from the front, then you insert the nuts from the back and the plates, the locking plates from the back, and then tighten them down. Don't use a wrench on these. You should be able to tighten these down with your fingers, and you'll notice that there are notches in those plastic nuts. You can reach in there with your thumbnail and push against the inside of the notch to snug them down really tight. Okay, now we've got these lighted push buttons mounted. Now we can concern ourselves with the common conductor. And before we do that, though, we also inserted the little normally open push buttons from the back side and then inserted the nuts on the front and tightened them down. Again, do not over tighten them, but you can tighten them down tighter than you can these plastic nuts on the back, because you don't want to split those nuts on the back. That'd be bad news, because I'm sure you didn't buy any more than 4 of these for your project. Okay, now we can solder the common terminal on there. Now, we already had this soldered on there once, right? And then you didn't, but I did. And that's when I realized, oh my, This isn't going to work. The solder was already there. All I had to do was lay the conductor on there, kind of wedge it in, solder one in, and then work it down in the other direction until they were all in position and soldered them up nice. You're using the practices you already learned in how to stabilize the two pieces of metal that you're soldering together. That is extremely important word to remember, stabilization. So before you apply the heat and solder, make sure that the conductor and the terminal cannot move when you apply the solder and the heat. You want it stabilized, and you want them in physical contact with each other when you solder them. The least accessible row is now complete. Again, this is not a perfectly clear picture, but it's good enough for you to see that the least accessible row of switches and lights is now basically complete. We put this one in first and finished it because once we put in the toggle switches, it wouldn't be as easy to get to these other connections. Insert the switch assembly. Make sure the alignment's right though. Remember, you had these toggle switches mounted from the other side. You soldered them all up, and all you had to do was flip them over, not rotate them. Or if you wanted to say rotate them on the axes of the common conductor and then into the holes. It should fit in there perfectly. So at this point, you're ready to start doing the interconnections inside the box. Okay, first thing you want to do is locate the red leads from the push button commons. There's 5 of them. Each of the 4 lighted push buttons has a red wire, and you can see them. I kind of bent them up into view there. They're a little blurry. This was the macro setting on the camera, probably. And you can't make everything in focus when you do that. But you can see those 4 red conductors kind of curled up towards the camera lens. And then over to the right, you see a 5th one, and that's the red common coming from those 2 simple, normally open push buttons. So we've got 5 conductors there that all need to connect it together. Now you could do this with a terminal strip, but if you use a terminal strip, it's going to be more work than you think, even though it looks neater when you're done. So we're going to connect them times 5 to the positive common. So that long positive common, remember we're going to cut out one little piece of that positive common over there between the green and the blue wire, because we don't want that going to the center tab on that toggle switch on the left. But for right now, just leave it there. So we're going to take these 5 red wires, we're going to connect them together, and then connect them to that long common connector. So to do that, we actually took the 5th wire, the long one that sticks way up there from the 2 little push buttons, the one with the highest yellow circle on it. We took that one and we pulled the insulation back. In other words, we pulled off maybe 1.5 inches of insulation off the end of the wire. Then we went down a couple inches and pulled the insulation towards the stripped end, so we had enough bare conductor there to twist these 4 wires around. Now, I didn't do a really neat job here. I only do typically, I try to be neat, but the main thing I'm after is functionality. Now at this point, it would have been better if I had taken those tails and kind of bent them a little bit more and bent them more flush, or bent them over so they were, parallel or flush with the main conductor instead of just sticking up like that. But it doesn't matter. They're going to solder fine. So at this point, you put the soldering in there and you start heating up all of those joints one at a time and applying solder. Don't apply so much heat, though, that you melt the insulation. Okay, here you can see that I did not push over the tails. I just soldered it and then cut off the excess. So now I'm going to slide on a piece of heat shrink tubing. And unfortunately, like I said, I didn't bend those over, so now I'm leaving some sharp points. I was a bad boy, I was. You slide a little piece of heat shrink tubing over there. You could use black electrical tape. I prefer heat shrink tubing. And I use direct contact with a soldering pencil to shrink the tubing very carefully. So once that tubing is on there, I slide it down over those soldered joints in a good 1/4 to 1/2 inch past, so none of the solder joint is exposed. Then I take the tip of the soldering pencil and I run it back and forth over that shrink tubing, applying heat directly to it. I don't have a heat gun, and I realize most of you are not going to have a heat gun either. If you do, that's great. But I also don't like throwing that much heat inside of the box and maybe damaging something else. So I tend to use the actual tip of the soldering pencil. Now, it does make the shrink tubing a little dirty looking on the outside. That doesn't matter. It's still going to do its job and isolate those bare conductors right there from the rest of the world. Okay, now you can see the shrink tubing there on the bottom with the wire sticking out of it. And you can see it's kind of tight down against all those conductors. You can even see a little gray smudge there on it from the soldering pencil. Nonetheless, the other end of that wire then, I took and bent it over that common positive conductor there and then soldered it to it. Again, you don't want to apply too much heat right there because you could melt the solder over to one of those terminals on the toggle switches and have it come loose. It's unlikely, but just watch what you're doing with the heat. So that was the next step, that joint right there. You can make yours neater, but you're not going to put heat shrink tubing over a T. Okay, now you remember that the push buttons and the toggle switches are connected in parallel. One side of each goes to positive DC. The other side, like the 2 yellow wires, the 2 green wires, the 2 orange wires, they have to be connected together and go as one conductor up to the input terminal on the PLC. So again, here you see another solder joint. Not real pretty. I apologize for that, but it worked. And some heat shrink tubing that I then slid over that ugly joint, used the tip of the soldering pencil to shrink it. That was the green one. Green. Do the same thing with the orange. That one's much nicer. So I felt guilty about that first one. So I made it a little neater. And I made all the rest of them pretty neat. But look, once that shrunk on there, the yellow was neater, but it doesn't look any better than the green once the shrink tubing's on it. I laid that piece of white paper in there just to make it easier to see that 2 green wires go into 1 green wire that's going to go outside of the box and it's going to go to an input terminal on the controller. Same with the yellow. We also needed to connect the DC power bulkhead connector. Now I want to point out something. See that the plastic insulation between the center terminal and the outer shell is black plastic? You want to avoid the ones that are white plastic. They seem to melt much easier. Remember I mentioned earlier about if you apply too much heat, then that plastic insulation melts and the pin gets displaced and it doesn't fit right. Now one way to fix that is to slide in the power jack on the other end, not plugged into the wall. Just slide one in there so it kind of holds things in place. Then solder the red wire to the center terminal. Now if you look closely, you'll see that it's not completely inserted into the little pocket, but it's soldered well enough that you'd never pull that off without destroying everything. It's a good solder joint. Then of course I use a little black shrink tubing or any shrink tubing over the negative side. That guarantees that the two can't come together and short. Now this is where I cut the common connection between the first toggle switch and the second toggle switch and solder in the conductor from the push button, the blue one, the one that has the blue wires in it, to connect the 2 switches in series. This can't be done until you reach this point. There's a better view. So you see there was a common conductor going from the toggle switch with the green wires over to the toggle switch with the blue wires. I cut out that section, used the soldering iron to remove any remnant from off the middle pin of the toggle switch on the far left, then took the blue wire from the push button right below it, slid it in there and soldered it to the center terminal. This is the touchiest, most critical point in this whole thing, is it's easy to booger it up at this point. So take your time. There's also something called a solder sucker or solder wick. A solder sucker is a cylinder with a spring-loaded piston. You push the piston down to the opening and it locks it against a spring, and then the opening is a tapered nylon tube or white plastic tip. You put that up against the solder that you want to remove, heat it up, hit the trigger, and the spring pops the piston to the other end of the cylinder and sucks the solder off of it. Or you can use, it's a little spool of finely braided copper wire. It's called solder wick, and it will wick it off of that joint. I'd use the solder sucker before I use the wick. It takes more heat to use the wick. Nonetheless, what we did right here, folks, was remove that piece of conductor that went the full length of the center tabs on the toggle switches to that last one, because that one we wanted connected in series with a push button, not parallel. Okay, electrically we've got everything connected. However, you could do a few more things while you're on this side of the project, and that is you could tidy up these conductors. Normally I wouldn't do that though until I had the top side all connected, and then I tested it to make sure it all worked, and then went and tidied it up, shortening and reconnecting any wires if I had to, if I really wanted it to look real neat and tidy. Now, since this was the first ever of this design for me to do, it's not as tidy as it could have been. But when you consider that these videos are made pro gratis, I don't rehearse them and I don't script them. I just take pictures as I'm going. I throw the pictures into a PowerPoint, and then I go through and narrate. I make mistakes. Sometimes I fix them, sometimes I don't. However, anything critical, I'm going to correct it, at least verbally or with a note, so you don't go off in the wrong direction. So at this point, you could tidy up the conductors. Because you're looking at my results, you could do yours to look much neater just by looking at these images and determining how long to cut each conductor and how to solder them together so it looks much neater than this. Flip to the top side. Now we're going to push up the conductors through the two holes, cut them to length. So you're going to, for instance, on this side, this is the input side. And I always start with the longest conductor. So I would find the white conductor, because I know that goes to the switch. We'll back up here. If you go all the way over to the right, you've got white, then brown, then orange, yellow, green, and blue. That's the order you want these hooked up in. So you want to make some notes before you go to the top side and make sure that you have your mind correctly oriented, so you know the relation of those toggle switches on the other side of the box that you can't see with the input terminals on this side. But I knew it was the white one, so I kind of stretched out the white one, kind of curled it up there, looked at where it would lay on the screw, cut it, stripped it, and then tightened it down under the pad, under the screw. Be very careful how you do that. Make sure that you don't have the insulation underneath the pad when you tighten it down. But you don't want to see a lot of bare conductor. If you look at the black conductor there, you can see a tiny bit of copper showing. It's going to the DC common right next in between input 4 and input 3. That's about the right amount. Not enough for you to actually come in contact with another object and short something out. Just enough so you can see that you don't have the insulation underneath the screw pad. So I did the white wire, then I did the brown one, and at this point I do the black common. So I cut a length of wire that goes from the DC common between 3 and 4 there, down to the box, and then up to the next DC common. And now 2 conductors are going to that pad. So while I'm at it, I cut another conductor that goes from that DC common to the very next terminal to the right that says not used. Now that's going to be my negative common. So then I can screw down the 2 DC commons under the DC common screw there. Then a black wire that came from the other side where the power went into, that comes up, and those 2 go under that one not used. Then the same thing with the 2 red. And voila, you do the same thing for the output side. And you can make this, you can make it a little neater than you want. That yellow strip of paper, I typically leave that on there. It's just a practice. In this case, it wasn't necessary. That's there to keep metallic debris and shavings from falling through the vents on the controller when you're doing construction. Because typically these controllers get mounted on a steel back plate. And then the back plate goes vertically into an enclosure. But it's laying down usually when you do the construction. As you're bending over, stripping wires, cutting wires, drilling holes, you create a lot of metallic debris inside the enclosure. And even though you might vacuum it out, blow it out, and actually blowing it out is not such a hot idea, I would vacuum it out really, really good. Then blow it out. Because if you blow it out first, you're going to blow all that metallic debris all around through the panel. You might get away with it, you might not. So I usually vacuum it out, then I blow it out, and then I stand it up straight. If you haven't cleaned all the debris out though, and you tip the panel up vertically, anything that's at the higher end could fall down into the vents on this controller or into your variable frequency drives or any of your other electronic devices. So I don't pull off this yellow strip of paper until I'm satisfied that all of the I/O wiring and wiring period has been wrung out. And when I say wrung, I mean as in like ringing a bell. Now, when you hear people say that, they wrung out the wiring. They really didn't. But it's a old-fashioned term used for verifying the wires are going where they're supposed to. And here's how they used to do it. They did it with a bell. An electrician would take a bell and hook it to two conductors on the far end of a run. Then he would take the same two conductors on the other end that he thought were those, at least the two he thought were the same, and put them onto a battery. If he heard the bell ring, then he knew that those two conductors were hooked to the bell on the other end, and he could mark them likewise. That was ringing out the wiring. So now they just say, did you ring out the wiring, or I've wrung out the wiring. Okay, voila, there it is. There's your finished project. At that point, though, you can see I don't have the plate on the bottom, so it's not actually totally finished, but I did check it for functionality. Add some felt pads on the bottom. You don't want to scratch up Mama's tabletop, not if you want to go on living and eating good. So add the little felt. That plastic normally doesn't scratch much, but if your screws aren't in all the way, you could leave a nasty little score on whatever surface you're working on. Then screw the base plate to the unit and you're ready to make some sparks. Well, I hope not that you're ready to make some sparks. You're just ready to do something. Well, that concludes part 2 of Build a PLC Trainer. There was another series of videos that we did building an advanced trainer. That one had a few sloppy points in it. It was a project that I was doing for my own use for some development, course development for RS Logix 5000, which is available at the PLC Professor website. I'm going to redo that one. I've purchased in the meantime some better components for that particular one, better meters and better potentiometers, etc. So there are actually 3 projects. The first one, Build a PLC Trainer, is probably the best one because it takes you through the simplest project and gets you on your way so you can purchase the manual, watch the videos free on YouTube, and learn how to program a basic PLC. The second one was Build an Advanced Trainer. It, I believe, had 10 inputs, 10 outputs. I mean, it had 10 toggle switches with 10 push buttons and 10 LEDs for outputs. And it had 2 potentiometers for analog inputs and 2 meters, 0 to 10 volt DC meters for analog outputs. That's the one I'm going to redo. This project that we just finished, Part 2a and 2b, is basically taking that Micrologix 10-point I/O controller as far as you can go with the demo. So thank you very much for watching. I hope you learned something and enjoyed yourself.